Hello everyone. So today we're going to talk about dependent sources, and we'll be looking at the differences between the independent and dependent sources, independent sources being the type of sources we've seen already in our simple circuits, and now the dependent sources, and these are the ones that you'll see the little diamond shapes, and we're going to look at then solving circuits when we have some dependent sources in them. So what is the difference between an independent and a dependent source? Well, as the name implies, independent sources do not depend on anything else. Their values are fixed, and anything else in the circuit could change. It doesn't matter, and the value of voltage across the component or the current through it remains the same. So it doesn't matter if resistors are changing or whatever is happening in the circuit, it remains exactly the same all the time. Dependent sources, by contrast, change the values depending on something else in the circuit. So here we have again a current source. So you can see here the current sources are in amps and the voltage sources are in volts, and these symbols are similar. For the current sources we have the arrow going through it, and the voltage sources we have the positive and negative. So now the dependent sources could depend on either a voltage or a current at some other part of the circuit. So here we have, in this case, KY volts or KY amps. This refers to some constant at some other point in the circuit. So let's look at an example of a circuit with independent sources only and with dependent sources, and then you'll get an idea of how they differ. So in the first example up here we have two independent sources. So we have 10 volts across here and we have 5 volts across here, and we want to find this current IS. So very simply, if we had to do this, we will say IS is 10 volts minus 5 volts on 11 ohms, 11 ohms being the sum of these two, and that gives us 5 on 11 amps. So that's very simple. Now if we have a dependent source instead, we know this is 10 volts here, but we have here 5 IS volts. Now notice that this is a voltage even though it says IS. IS is the dependent variable. So this is the variable that the voltage depends on. So we have IS, which is here, and the value of voltage across this source is 5 times the value of IS. So unlike the first example, when we knew it was 5 volts, we don't actually know what this value 5IS is. So and also it is a common mistake is that students often think that because you see IS here, it's a current. It's not a current, it's a voltage, and we could tell that by the source here. So how would we go about solving this circuit now? Now we have 10 volts and we have the voltage here. We don't know what it is, we just know it is 5 IS volts. So just like before in the previous example with the independent source, when this was 5 volts, we had 10 volts minus 5 volts on 11. Now we have the same thing, except instead of 11 we have the 5 IS volts. So we have here, as you could see, 10 minus 5 IS over 11, and from that we have one equation with one unknown. So we could solve for IS, and we get IS is 10 on 16 amps. Now what happens if we have a dependent source in the circuit by itself. So if we look at this circuit, we short-circuited the voltage source from the last example, so we have no 10 volt source here. So in this case, we have the current, which is Is in this direction, is equal to 0. We could say Is is equal to 0 minus 5 Is on 11. Previously we had 10 minus 5 Is. Since we short-circuited the source, that 10 has now become 0. So again, we could solve for Is here, and if we solve for it, we will see that Is is 0. So that's a very interesting result. What does this tell us? What does it mean if, when we have a dependent source alone, the currents and the voltages and so on work out to 0? So it tells us that they are not able to supply their own energy to the circuit, which is what an independent source does. They require independent sources to have some non-zero value of voltage or current. So before, when we had the 10 volt source, we saw that we got a non-zero value for the voltage, for the current. I think it was 10 on 16 amps. And then when we removed it, you got 0. So do we know any other components that behave like this, that require a voltage or current source in order to have a non-zero value? So if you think about it, what you would see is that resistors do that. If you just have a resistor in a circuit with no source, there's no voltage, there's no current, just like a dependent source. So although the dependent sources are called sources, they actually behave like passive components. And you could even try replacing a resistor with a dependent source. So all it means is that the source would depend on in this case, the current flowing through it. So I could take this example, which would be 10 volts, 5 volts, and I have 6 ohms here. If I had to find the current through it, I would get 10 minus 5 on 6, which is 5 on 6 amps. I could also represent that with a dependent source, and I just take the value of the resistor and I multiply it by the current through it. So I know Is is through it because we know the value of the voltage here, VR, is equal to RIS. This is the same as having a dependent voltage source, which is R by IS. So if I work out the value of the current in this case, I will get 6Is, which is the voltage across here, is equal to 10 minus 5, and that will give me 5 on 6 amps, which is exactly the same as before. So let's get a little more complicated now and see if you could work out the value of IA here. So pause the video and see if you could work out what that value is, and you'll have to use all the things you learned before, like the current law and Ohm's law and all of those things. Good. So if you did that now, you should have some working and something for an answer. Don't worry if it's right or wrong now. Let's just see how we're going to go about this. So we want to find IA. I'm just going to define some other points, some other voltages and currents in the circuit. So the first thing is I'm going to take this node here and call it VA. And then I'm going to look at this current and call that IX. So now I've defined sort of all the voltages and currents in my system. And I have here a current source, a dependent current source, even though it's 2Vx. Remember, the thing we have to look at is the symbol, and the symbol is the symbol for the current source. So this means that this represents a current of 2Vx in this direction. And similarly, we have 3Is, but this is a dependent voltage source, which means that the value of voltage here is 3Is. So right away we could say that VA is equal to 3Is because this voltage source here tells us that. Now if we want to find the current IA, we could start off by looking at what is the value of Is. We need to find the value of Is to find VA. So we say Is we know is 10 volts because we have 10 volts across here, which is the same as the voltage across the 5 ohm resistor. So Is is 10 on 5, which is 2 amps. The next thing I want to do is I want to find VA. I know VA is equal to 3Is because it is fixed by this resistor, this dependent voltage source. So 3Is, which is 3 by 2, 6 volts. So if this is 6 volts, then I could say Vx is 10 minus 6, which will be 4 volts. And if I have 4 volts across the 6 ohm resistor, then the current through it, which is Ix, will be 10 minus 6 on 6, which is 4 over 6, which is 0.667 amps. So I've calculated the current Ix, which is here 0.67 amps. And I know the voltage here Vx, which is 4 volts. And I still need to find the current IA. So I have this current. I want to find IA, so I need to find what is the current here. And then that will allow me to use Kirchhoff's current law to find what is the value of IA. So I know the current here is 2Vx, and I know Vx is 4 volts. So I have 2 by 4, which is 8 amps. So now I have 0.67 amps, 8 amps, and I have IA down here. So we can see that the current goes this way, and IA will be equal to Ix plus 2Vx, which is 8.667 amps. I could also write it the way we were doing before and look at all the currents coming in to the node, and that would give me 0.67 plus 8, and this current going into the node here is minus IA is equal to 0, so I'll get IA is equal to 8.67 amps, exactly the same. Good. So in summary, we looked at the differences between independent and dependent sources, and we looked at solving very simple circuits with dependent sources. So remember, independent sources, the values do not change regardless of what is happening in the circuit, and dependent sources, the value will change depending on if resistances change or if other independent sources change. Whatever happens in the circuit that causes a change, it will affect the value of the dependent source. And also remember, to determine the type of source that we're working with, we have to look at the symbol, because a dependent voltage source could depend on a voltage or a current. So sometimes you might get confused if you see 3I volts. So the I will be the dependent variable, the thing that that voltage source is depending on. So that brings us to the end for today.